Hello, this is Mrs. Marquette. Today we're going to talk about solving rational equations. So in the last couple lessons, we've been talking about rational expressions, simplifying, adding and subtracting, finding LCDs, and we're going to kind of tie it all together today with solving. But to do that, we have to go back and look at all of the different ways that we solved back in other chapters. So solving equations. If I look at number 1, I've got x squared plus x minus 2 equals 0. We remember that when we have got a squared, that's a quadratic, okay? And quadratics can be solved either with square root method or by factoring. I'm going to solve this one by factoring. So I'm going to first factor the left side. So I get x and x. I need something that adds to 1 and multiplies to negative 2. That'll be positive 2 and negative 1. And remember that when we have something that's factored, we want to set each piece equal to 0. So x plus 2 equals 0. X minus 1 equals 0, right? So if I subtract 2 from both sides, I'll get x equals negative 2. Add 1 to both sides, and x equals 1. So my two answers, my two solutions in this case, are x equals negative 2 and x equals 1. Remember what that means. Solutions to equations means those numbers will make the equation true. So if I plug in 1 into my equation, 1 squared is 1, plus 1 is 2, minus 2 is 0, so 0 equals 0. All right, that's going to work with negative 2 as well. Number 2, I have 6x equals negative 18. I am looking to get x by itself, so I know what x equals to make the equation true. I can divide by 6 on both sides and get x equals negative 3. Just to double check, 6 times negative 3 is negative 18, so that is a true equation, a true solution. Number 3, I've got a little more going on. I'm going to do PEMDAS backwards, meaning I subtract 4 from both sides and get 2x equals 8. Divide by 2 on both sides, and x equals 4. So this should really be some review for you guys, making sure you remember your factoring, but also just remembering how to solve equations. We're going to be doing that a lot inside of problems today. Number 4, you can either add 16 to both sides and then take a square root. I'm going to choose to factor. I'll get x and x. To multiply to negative 16 and add to 0, I'll get plus 4 and minus 4. So x is equal to plus or minus 4. Those are two solutions. And number 5. X cubed minus 25x. Notice we've got a power higher than 2, so we're definitely going to be factoring. I do notice a GCF. So x and then x squared minus 25 equals 0. I can keep factoring because I see a difference of squares. And then x plus 5, x minus 5 is equal to 0. My three answers are 0, and then positive negative 5. That is because x minus 5 equals 0 will give me a positive 5 answer, and x plus 5 equals 0 will give me a negative 5 answer. So if that is not looking familiar, I need you to go back and review some solving notes, both with factoring and solving linear equations. When we solve rational equations, I'm always going to have 3 steps. Okay, the first step is I'm going to find the LCD. Okay, so looking at number 1, we have different denominators, so we're going to have to find that LCD. The second thing I'm going to do is I'm going to make the denominators equal. So make denominators equal the LCD specifically. Okay, and we're going to do that by multiplying something on the top and on the bottom. And the last thing that we're going to do is we are going to set the numerators equal to each other. The reason that's going to work is because we're already going to have the denominators equal to each other. So then, in order to make the whole equation equal, then we'll make the numerators equal to each other. So I'll show you how that works in just a second. Looking at number 1, let's find that LCD. Okay, so the LCD, remember, is found by not double counting, not leaving anything out. So I start with the first denominator. That's x. Okay, so that has to be included in the LCD. Second denominator, don't double count, so it's not already in there, and we don't want to leave anything out, so 2 has to be included as well. Looking at the last denominator, It's an x. I don't want to double count it, and since x is already there, I can just leave it as is. So my LCD is 2x. I want to make all my denominators look exactly like 2x. So I'll multiply by 2 on the top and bottom, multiply by x on the top and bottom, and multiply by 2 on the top and bottom. What that's going to mean for me is I'll get 8 over 2x plus 5x over 2x is equal to negative 22 over 2x. Okay, what I have accomplished here is I have made all of the denominators look the same. Okay, remember that equations have to be exactly equal on the left and the right. So if I have equal denominators on the left and right, really all I need is for the numerators to also be equal. Here's what that is going to look like. I can say now that 8 plus 5x has to be negative 22. That's the only way to get the denominators and the numerators equal. So I'll say 8 plus 5x equals negative 22. I'll subtract 8 from both sides. So I get 5x is equal to negative 30. Divide by 5 on both sides. And x is equal to negative 6. Okay, if I think about plugging that back in, I already have the x's equal on the bottom, so if I plug in negative 6, I'll get negative 12, and negative 12. But then I get 8 plus negative 30 equals negative 22, and that's a true statement. Okay, the last thing I have to think about is, does this work as a fraction? Okay, because remember that when I have fractions, division by 0, or when my denominator is 0, I have a problem. So the denominator can never be 0, right? That's impossible. So I've got to check, does that negative 6 ever make the denominator 0? So if I look at my denominators, I got to decide, what can x not be? Okay, so x definitely cannot be 0, because if I plug in 0, I'm going to get 2 times 0 is 0. But any other number that I plug in is going to be fine. So since x can't be 0 and x is equal to negative 6 is a good solution. Number 2. Okay, why don't we start first of all with what x can't be? I think that'll help us set up for later on down the road. So I have x cannot make the denominator equal to 0. Looking at this denominator, if I plug in positive 2, then 2 minus 2 is equal to 0, and that's a bad thing. Okay. Same with this one. Plug in 2, I get 2 minus 2 equals 0, and that is not good. So all I can't have is x is not allowed to be 2. All right, so now I look at the LCD. Okay, the first denominator is x minus 2, so I've got to include it. The second denominator is just 1, so I can multiply by 1, but I don't really need to. And then the last denominator is x minus 2, so don't double count, don't leave anything out. X minus 2 is already in the denominator, so I don't have to worry about it. So my LCD is just x minus 2. I want to make every single denominator look just like that. So x minus 2 is already there. I've got to make this denominator, x minus 2, multiply by x minus 2, and then the last denominator is already okay. So I've got 5x over x minus 2 equals 7x minus 2 over x minus 2 plus 10 over x minus 2. All my denominators are equal. That's good, okay, because that means that I can just set the numerators equal to each other. So 5x is equal to 7x minus 14. I distributed that 7 plus 10. All right, that's a much more simple equation for us to deal with. It's something that we've done many times. Okay, I can subtract 7x from both sides. Get negative 2x is equal to, then I can combine like terms, negative 4. Divide by negative 2 on both sides, and x is equal to 2. So that is my answer, but remember that I already said that x cannot be 2, right? So x equals 2 would be my answer, but if I plug it in, I'm going to get a 0 in the denominator. What that means for us is that we have an extraneous solution. meaning that x equals 2 would be the answer, but it's disqualified because it makes our answer give us an error. Okay, so now we kind of see how important it is to check our denominators right away. So notice in this denominator, if I have x equals 0, I'm going to have an issue. I'm going to have a 0 in the denominator. So if we get in the end that x equals 0, we got to throw it out, just like we did on the last one. So LCD is going to be 2x, because I can multiply by 2 on the top and bottom for the first, and x on the top and bottom for the second, and I will have the same denominator. Okay, so now I write 2 times 4x minus 1 over 2x equals x squared plus 5x over 2x. The second, notice I distributed this one. I guess I'll just distribute this right away too. So 2x times 4x, or 2 times 4x is 8x, and then minus 2. Okay, I've got equal denominators, so I can set the numerators equal to each other as well. 8x minus 2 equals x squared plus 5x. And now we've actually got a lot going on. We've got x's and x squareds. So I want to remind you about what we did right at the beginning. When we have an x squared in our problem, we want to factor. So we want to get everything on the same side so that we can factor. Subtract 8x on both sides and add 2 on both sides. Okay, because I want to get everything on the same side, x squared minus 3x plus 2, because now I can go ahead and factor. Okay, I get 0 is equal, and I know that I want to set up my parentheses. I want numbers that multiply to negative, or add to negative 3, multiply to positive 2. That's going to be negative 2 and negative 1. Okay, so now I get x minus 2 equals 0, x minus 1 equals 0, and x is going to either equal 2 and 1. Okay, but I've got to check, are either of those bad answers? So x can't equal 0, which is fine because x doesn't. X equals 2 and 1. So those are my 2 answers. So that is solving with LCD. You make your LCD, you make the denominators equal, then you make the numerators equal. The other way to solve with expressions that have fractions or rational equations is by cross-multiplying. You might remember this way back in middle school by, if I've got one fraction equaling another fraction, I can cross-multiply. Okay, the really important thing about cross-multiplying is I do 3 times 4, and it has to equal 8 times x. Okay, that equal sign can't get lost while you're doing your problem. So don't forget about this equal sign. Okay, so then I get 12 equals 8x, and that's a very simple equation for me to solve. Divide by 8 on both sides, and x is equal to 12 over 8, which is 3 over 2. Or if you gave me 1.5, that would be fine. Either one. Okay, but this can get a little more complicated. When I cross-multiply in this problem, I get 3 times x plus 1 is equal to 4 times x. Okay, don't forget about the equal sign. The reason I'm going to write it down like this is because I've got to remember to distribute that 3. So I get 3x plus 3 is equal to 4x, and I can solve this problem. Subtract 3x on both sides, and 3 is equal to 1x, or just x. On both of these problems, I didn't have x's in the bottom, so I don't need to worry about what x can't be. But looking at number 7, I do, because notice I've got x's in both of my denominators. So it's the same rule. What can't x be? X definitely can't be 0, because that'll make the first denominator 0. X also can't be negative 1. So just be on the lookout for those answers that we got to throw out. Cross multiply, I get 6 times x plus 1 equals 2 times 2x, and I get 6x plus 6 equal to 4x. Okay, keep solving. I'm going to subtract 6x on both sides and get 6 is equal to negative 2x. Then divide by negative 2 on both sides. Okay, so I get x is equal to negative 3. In this case, again, x can't equal 0 or -1, but x equals -3. So that is absolutely fine. So sometimes cross-multiplying is a much nicer way to solve. Specifically, you can cross-multiply when you have one fraction equaling another. So that has to be the case. Notice LCD, sometimes we have 3 fractions. When that's the case, we've got to do LCD. But cross-multiplying is okay when you have 2 fractions. Okay, just one more problem. I look at number 8, 2 over x squared minus 2x equals 1 over x minus 2. And I only have 2 fractions, so I can choose to cross multiply. So before I start that, I want to look at what is possible to make this denominator 0. Okay, so looking at that second denominator, x definitely can't be 2. To see what the first denominator can't be, I'm going to factor. So x and then x minus 2. So x can't be 2, x also can't be 0. Okay, so now I can cross multiply. I get 2 times x minus 2, and then 1 times x squared minus 2x. Okay, so I get 2x minus 4 equals x squared minus 2x. Again, I've got this x squared going on, so I want to see that I'm factoring. So bring everything over to the same side, minus 2x, and then plus 4, plus 4. I get 0 equals x squared minus 4x plus 4. Okay, this is good because I can factor. 0 is x and x. I need 2 things that multiply to 4 and add to -4. That'll be -2 and -2. Okay, so I get x minus 2 equals 0, x minus 2 equals 0, so x is equal to 2 in both cases, right? But remember that x cannot equal 2, right? It's impossible because it makes the denominator 0. So in this case, I have to again say that this is an extraneous solution. Meaning that x equals 2 should be our solution, except that it makes the fraction with the denominator of 0, so we have to throw it out. So in this case, we really have no solution to this problem. So these are the 2 concepts that I really want you to be practicing. The cross multiplying I think you'll be more comfortable with. That's when you have 2 fractions. Don't forget the equal sign in the middle. But the LCD problems are important to practice because you have to use LCD when you have 3 fractions. So don't skip the practice problems tonight and come and see me with any questions. Bye guys.